Hey guys, this video we're going to take a look at Pascal's triangle, which is a really useful tool and trick to help you multiply out some binomials and things like that. So this lesson, as well as our next one, they tie together very closely, but today this focus will be on Pascal's triangle, which is this triangle right here. It's a triangle of numbers, and there's tons of patterns. First of all, there's ones going down the sides. The next space in, if you kind of look diagonally, going this way like this, the numbers are counting up. Same thing going this way. It's also symmetric, straight down the middle there. That's what this line is here for. I can show you that symmetry. You can see that matches up. So like down here, 1, 6, 15, 20 in the middle, and then 15, 6, 1. It is symmetric. That's the same numbers. They repeat. Once it builds up, then it just starts coming back down. And then the last one is the last pattern that, at least that I notice and pay attention to, is based off of these little blue lines right here. When you combine these top two numbers to get the next, you just add them up. 4 plus 6 is 10, 6 plus 4 is 10, 1 plus 4 is 5. So you just add up to get the next row. So this next row here would start with a 1, because everything starts with a 1. It's also going to end with a 1, but we'll get there when we get there. Then here in the middle of 1 and 7, we're going to get 8, and then 7 and 21 is 28. These numbers are getting a little bit large, but 21 plus 35 is 56. 35 and 35 is 70, and now those numbers are going to start repeating again. 56, 28, 8, and 1. So you can continue this triangle forever if you wanted to. The only thing stopping you is the amount of time it's going to take and how boring it is after here, honestly. So, or maybe like after way up there. But yeah, so let's take a look at how to use this. So the triangle is used to expand binomials. So when you're expanding something to the first power, you just take that first full row, not the one that starts at the top, but this is first, second, third, fourth. I call those the rows. I call row 0. It just doesn't, I don't count it to the top. So to the first power, you get a 1 and a 1, which are the numbers from the triangle. From the second power, we expand that out, you would get 1, 2, and 1 as coefficients, 1, 3, 3, 1 as coefficients, and those are the numbers in the triangle. So this pattern follows whatever we're expanding, as long as there's no coefficients. That's the word I'm looking for. No coefficients on this. Otherwise, if there is coefficients, these numbers will change, and we will get to that. So we will start by expanding x plus y to the third. So that exponent there tells us that we're going to row 3. Remember, this is row 0, row 1, row 2, row 3. You can also just look at the second number. That'll tell you what row you're in. So we're taking 1, 3, 3, 1. I don't know where that just went. That's funny. Bring it back. It's gone. There it is. Alright, so we've got 1, 3, 3, 1. We want these nice and spaced out so we can use these. Now the next thing that we are doing is next to each of these numbers, we need 2 sets of parentheses. And plus signs here in the middle. Now in your parentheses, the first term of your binomial that you're multiplying out, the first term goes here in the first parenthesis, and the second term goes here in the second parenthesis. If there's a number there, you'd still put that number. If it was 3y, you'd fill it with 3y. So we're starting easy. Now the last part to this is you fill in exponents on these parentheses. And that is also pretty easy because all you have to do is count. You just have to count on the first parenthesis. We're counting down. 3, 2, 1, 0. And then I work my way back. Once I get to the end, I work my way back. 3, 2, 1, 0. So first count down exponents to the right, and then count down exponents starting over from right to left. Once you have this written out, it's just basic math. It's like Algebra 1 type math. We got 1x to the third times y to the 0. We're just simplifying this. So that would just be x to the third, 1x to the third. Y to the 0 is 1, so we don't have to write it. 3x squared y. And then 3xy squared. And then 1, x to the 0 is 1, y to the third. And that's it. That's expanding a binomial to any power. It's going to follow this shortcut. We're going to take the numbers from the triangle, 2 parentheses for each of those numbers, 1 for each term, and then the exponents, and then just work it out and simplify. All right, so here we go again. Y, this is x plus y to the 6th, which means we're taking the 6th row here. 1, so starting with a 1, parenthesis, parenthesis, and then a 6, parenthesis, parenthesis, 15, 2 parentheses, and then a 20, or 2 parentheses, and then a 15. Obviously, I'm out of space, so if you do happen to run out of space, just move it down to the next line. That's okay. 7, and then not a 7, a 6. Whoops. It should also be symmetric, right? So the 6s need to match, and now our 1s need to match. Make sure we're looking at the correct row. All right, now we fill in. X goes first. And then we're going to fill in the y next. It's positive, we would take that sign with it also. And now we're going to fill in our exponents. We're going to count down starting at 6. And then we're going to count up, going back. 6, 5, 4, 3, 2, 1, 0. Now, maybe you noticed this, maybe you didn't, but the 2 exponents will always add to equal 6. 5 plus 1, 6. 4 plus 2, 6. 3 plus 3, 6. They always add. So if you think you messed up an exponent, just double check. Make sure they add up to equal the original exponent. All right, so now we got to work it out. There's no numbers involved with these exponents, so this is going to be super easy. It's going to be 1x to the 6th plus 6x to the 5th, and then y to the 1st. 15x to the 4th, y squared. 20x to the 3rd, y to the 3rd. 15x squared, y to the 4th. Now, you can probably, especially when it's no numbers involved, I was just showing you the way that I always set it up. But when there's no numbers involved, you can skip the parentheses and doing all of that stuff. Where are we at? 6x y to the 5th. And then last, it's going to be a 1. X to the 0 is 1. Y to the 6th. So let me just get our triangle out of the way, and there's our answer. So this one, we're going to step it up just a little bit. Again, that's a 5, so we're looking at row 5 here. 1, and then 5, 10, another 10, and then a 5, and then lastly we have our 1. We fill in our m first, and then we'll fill in the negative n. So we'll have to pay close attention here, because now we have a negative exponent, or a negative variable with exponents, I should say. Now we fill in our exponents, starting with a 5, 4, 3, 2, 1, 0, and again 5, 4, 3, 2, 1, 0. So the zeros are gone. That leaves us with m to the 5th. And now we have a negative n to the 1st, so that's going to be a negative. Now we've got the 5, m to the 4th, and then n to the 1st. Just make sure you keep track of your negative. I always look at the negatives first, just like I modeled right there. All right, now it's negative squared. It'll turn positive. 10 m to the 3rd n squared. This one's going to turn negative because it's negative to an odd. And next, let's see, we just did our 10 and our 10. Now we're on to the 5. Negative to the even is going to be positive, so positive 5, mn to the 4th. And then our last term right here is going to be 1 times 1, and this will be negative because it's to an odd, n to the 5th. There we go. So that threw in a negative just to show you that you do have to keep track of it. When we throw in a number, it gets a little more complicated. Still, really not that bad. A little time consuming, because you got to set these all the way up and everything, but not that bad. It's way better than multiplying, like doing all your distributing and all of that sort of stuff. Way, way better. All right, so here's our row. It's a 4 for the exponent, so we're at row 4 there. So we're taking our numbers, 1, and then our 2 parentheses, and then 4, 2 parentheses, and then 6 with our 2, 4, and 1. Now we'll fill in variables, or the terms, I guess, that go there. Negative 3x. And last, we're going to fill in the exponents, counting from 4. Now, going to get a little crazy here. We're going to just use the fact that they always have to add up to be 4, so we don't need to count. We can fill in whichever one we want because they're going to add up to be 4. This is just going to help us with a skill later. That's the only thing. So if that's a 2, that's a 2. If that's a 3, 1. 1, that's going to be a 3. 4 is going to go with 0. 0 is going to go with 4. Doesn't matter how you fill them in because you know they have to add to be 4, the original exponent. All right, to the 0 doesn't matter. To the 0 doesn't matter. We can cross those out. So we have 1 times 1 to the 4th, just 1. Now we have 4 times 1 to the 3rd is 1. So 4 times 1 is 4. And then negative 3 to the 1st is negative 3x. So we're multiplying this out. 4 times 1 times negative 3 is negative 12. So I guess I should erase my sign I just wrote. and that's going to be x to the first. All right, now we've got negative to even, so that's going to turn positive, so I can put my plus now. That's going to be 6 times 1, and this is 9x squared times 1 times 6. 6 times 9 is 54. Negative 3 to the third. It's going to be negative 27 x to the third. 1 obviously doesn't matter, and the 4 doesn't really matter there. But it is negative 27 times 1 times 4. So that's negative 100. 108 x to the third. And then last, the only part that we need to work out ahead of time here is this negative 3 to the fourth. 3 to the fourth is 81, so it'll be positive 81 x to the fourth times 1 times 1. So that's it. It's really about as hard as they get, other than maybe having a number in both spots. So we will look at that right now. Again, we got a 4 here, so it's 1. Oh, hopefully my pen doesn't get too crazy here. Remember, this will be a 2x and a negative 3y, followed by a, taking this row here, I'll circle it, 4, and then 2x negative 3y, followed by a 6, 2x negative 3y, followed by a 4, and then last we have a 1, and now we'll fill in our exponents. So remember, first we count down from 4, and then the other one we can either count backwards, we can count however we want, because we know they're going to add to be 4. 3 plus 1 and 0 plus 4. So do whatever in between step you need to do. To the 0 goes away, doesn't matter. 2 to the fourth is 16. And that'll be x to the fourth. 2 to the third, that's 8. And then negative 3 to the first is negative 3 times 4. So we're just multiplying those 3 numbers there. It will be negative. 8 times 3 is 24. 24 times 4 is 96. And we got an x to the third and a y to the first. 2 squared is 4. Negative 3 squared is positive 9. However you want to multiply, let's do 6 times 9 is 54 times 4. It's going to be 216. And then we got an x squared and a y squared. 2 to the first is 2. Negative 3 to the third is negative 27. So that's negative 27 times 4 is going to be negative here. That's 108 times 2, 216. And again, you can pull out a basic calculator or whatever, or write for the multiplying if you cannot do it in your head. Don't feel bad. It's okay. All right, and then we've got 2 to the 0, cancels out. Negative 3 to the 4th is 81, positive 81. So that will be positive 1 times 1 times 81. The x is gone, but we got y to the 4th. That's it. All right, so we're going to continue this just a little bit more, make it a little bit easier. All we need to understand with this part is that these numbers can be found even more easily by using a row and position. So we talked about rows already. I always start calling that row 0, row 1, row 2. Position starts the same way. All of these ones would be position 0, the way I call them. N represents the row, R represents the position. It's just the positioning that we're going to label these variables here. You can find these however you wanted to. So let's find this highlighted one. There's a formula for it. It's built into your calculator. There's also a way to calculate it by hand, but I'll show you both real quick. So this one right here, this highlighted one, this would be row 7. Remember, the first number tells you the row, which matches up with the exponent in the problem. So row 7, and then this would be position 0, 1, 2, 3, 4, 5. Just remember to start counting with a 0 there. So row 7, position 5, you could write that as 7C5, or the other way to write it is this notation with just parentheses here. You just put 7 over a 5 like that. It's not a fraction, it's just a notation. Now on your calculator, you get to this by doing, from the main part of the calculator, option. We're going to start at the option section, scroll over to probability, because that's where this is actually another place where this is used, probability. And then right there, it's the NCR, just like we have written. So if you wanted 7C5, you just type in 7, and then that NCR button, and then a 5. The answer is 21. There is a way to do it by hand. I'll show that here at the bottom of this page. So row 5, position 4, that'll be 5C4 is the number 5. Now let's find that on our triangle. We'll match it up. Row 5 would be this row. Position 4 would be, remember we start at 0, 0, 1, 2, 3, 4. So that's row 5, position 4. So it is 5. The answer is 5 there. Got it from the calculator, got it from the triangle. You can find those numbers that way just using that calculation. Okay, so the other way to do it by hand, I'll never make you do this. It's not terribly difficult though. Row 7, position 5. Let's do that one. That was a little bit more challenging, I think. The second number would tell you how many to write out, how many spaces we need. On top of those, we're going to start counting at 7 and count down until they're filled up. And then on the bottom, we start counting at the other number, 5, and count down until they're filled up. You're always going to end with 1 there. It's always going to count down perfectly because, well, that's how many spots you wrote. Now, canceling out, you can cancel out anything on top with anything on bottom because this is all multiplication. So 5 cancels 5. 4 cancels 4. 3 cancels 3. This 2, you can even reduce the 6 to a 3, and then our answer here is just 7 times 3, which is 21. So it's not difficult to do them by hand. It's a lot of writing. probably easier on the calculator, so that's the way we'll do that. So computing each of these, let's just type them into our calculator. This would be 3C0. Remember, that means row 3, position 0. So the first spot, which we know is always a 1. Row 3, position 1. So that's the next number over, position 0, position 1, which you might know the answer just from the triangle. 3C1. The next number over would be 3. Remember, it's always the row that you're in for position 1. The next number, maybe you don't remember that, so maybe this will be a surprise. 3C2, that's a 3 also. And lastly, 3C3, not 33, that'd be an error if I would have hit enter on that, is 1. And that should make sense because the third row of Pascal's triangle is 1, 3, 3, 1. So, but that's just calculating those out. Super easy. All right, 11, C7. $330. And then 12C8, same thing. Type it in. 12C8. 495. That's it. All right, let's take a look at another way to do this. So when you are asked to just find a certain term, you don't need to do the entire expansion. You don't need the entire triangle. We just need a certain term. So we need to know what row we're in. We need to know what position we're in. So the row always matches the exponent. So the row is 5. The position is not the same as the term. The position, remember, starts counting with 0. So if we're counting out to the 4th term, that means we're counting out 0, 1, 2, 3. We're in position 3. It's always going to be just minus 1. Term minus 1 is always how you get position. And then the row is always the exponent. So if that's the term we're trying to find, in Pascal's triangle, when we started these, we started with the coefficient, followed by 2 parentheses, the 1 and the negative 2x. We're going to fill in our coefficient now, but we're not even going to fill it in with a number. We're going to fill it in with what we're going to get from our calculator first. Row 5, position 3 just means we would do row 5, position 3, which would be row 5, position 3. Why does it keep doing 33? So that's a 10. All right, now we need our exponents. That's the only part that's missing here. So again, when you think about those, our exponents start with, we start with a 5 and a 0, and then a 4 and a 1, and a 3 and a 2 and a 2 and a 3. They always add up to be 5. But if you notice that second exponent, the one that would go here, follows the position. Again, position, not the term, but the position. If we go back to one of these examples we did, this would be term 1, term 2, term 3, but it's position 0, position 1, position 2, position 3, position 4, because they count up starting with 0. So that back exponent will always follow the position. So that's super easy. Position is row minus 1. Position is row minus 1, or term minus 1, sorry. And then that back exponent is position. And then the 2 exponents you know have to add. So since that's a 5, this is a 3, this one has to be 2. Because they're going to add. Come on. There we go. So we do 1 squared is 1, and then we do negative 2 to the third. That's negative 8 x to the third. Multiply out, and we get negative 80 x to the third. So row is the exponent, position is term minus 1, and then position always matches your second exponent there. So our row is 11, our position is term minus 1, so 8. Our first piece is 3x, our second piece is negative y. The bottom number is our second exponent, the position is our exponent, and then they have to add to equal 11. So that means this is 3. So this is 3 to the third, 27, negative 1 to the 8 is going to be positive y to the 8th. And then 11c8. Let's move that over so we can see. 11c8 is 165. And then we're multiplying 165 times 27 times 1. 4455. And then it's x to the third, y to the 8th. Remember, those will always add to be 11, the exponent in the problem. That's it. So go ahead, you can find the homework. This actually is all the notes you need for both 9.1 and 9.2. So you can complete both worksheets, get them submitted into their appropriate spots, and post your comments and questions as always. And I'll see you in the next one. Bye.